A basic system consists of the battery, to provide a source of energy, the ignition switch, to provide driver control over system operation, an ignition coil, to provide a step-up transformer action, a contact breaker, opened and closed by lobes on the distributor cam as the engine rotates to make and break the primary circuit at the correct time in the cycle, a capacitor, to assist in the rapid collapse of the coil's magnetic field, a distributor, to house the contact breaker and distribute the high tension voltage from the ignition coil and spark plugs to ignite the air-fuel mixture in each cylinder in the correct firing order. Connecting wires and leads suitable for conducting the current flowing in the system at the appropriate voltage level. When these components are connected together, they form two distinct circuits, primary and secondary. In the primary circuit, the positive terminal of the battery is connected to the ignition switch, then to the positive terminal of the ignition coil. A connection is then made from the negative terminal to the contact breaker moving contact point. The fixed contact point is connected to ground at the vehicle frame, as is the negative battery terminal. This allows the circuit to be completed through the frame when current is flowing. A capacitor is connected in parallel with the moving contact and also has a ground connection through its retaining screw. In the secondary circuit, the secondary winding with many thousands of turns of fine enameled copper wire is wound around a central soft iron core. It is connected internally to the primary winding at one end and at the other to the central output terminal, also called the HT or high tension terminal. The central coil terminal is then connected by a high tension lead or cable to the center terminal of the distributor cap. A spring-loaded carbon brush connects the terminal to the center of the rotor arm or button. This ensures contact is made with the rotor arm at all times, even when the engine is running. As the rotor arm rotates, it lines up with the segment inside the distributor cap, which leads to the spark plug for that cylinder. With the ignition switched on and the contact breaker closed, current flows from the positive battery terminal through the ignition switch, the primary winding, and the contact breaker to ground, then back to the negative battery terminal. The current flow establishes a magnetic field around the windings. The field is intensified by the rod-shaped laminated iron core. With engine rotation, the lobe on the distributor cam acts on the heel of the moving contact point at the instant ignition is required. This opens the contacts and stops current flow through the primary circuit. This sudden interruption of current flow collapses the magnetic field, and it returns its stored energy to the coil terminals by cutting across the coil windings. This induces a voltage in the primary and secondary winding. Since the secondary winding has about 100 times as many turns as the primary winding, the secondary voltage can also be about 100 times greater than the induced primary voltage. As the high tension voltage builds up across the ends of the secondary winding, a voltage level is reached where the spark plug gap suddenly becomes conductive. A spark then bridges the gap between the rotor and the distributor cap segment, and also the gap between the spark plug electrodes. The secondary circuit is from its connecting point at the primary winding to the spark plug and across its electrodes to ground. From there, it is completed through the battery and primary circuit back to its connecting point. Opening and closing the contact breaker switches the primary current off and on. When the contacts begin to separate, the primary current tends to flow on and produce an arc across the contacts. The capacitor absorbs this surge of inductive current by providing an alternative path in parallel with the opening contacts.